Okay guys, it's Miss Johnson and I'm here to bring you our last notes video for Unit 3. Unit 3 Note 7, which is on multiplying binomials. So, holy cow, we have a couple of methods here that we can use to multiply binomials. The first one is called the FOIL method, and the FOIL method looks like this. These are the steps that you would use. What happens with the FOIL method is it's an acronym, FOIL. We multiply the first terms inside the parentheses, then we multiply the outside terms together, then the inside terms, then the last, F-O-I-L, FOIL. We combine anything that we can, and we put it in standard form. Okay, and I'm going to do examples of both of these. Okay, so that's one way to organize our thought process here. Really what's happening when we're multiplying binomials is that we have two sets of distribution going on. So we just need a good way to organize all of the things that we're multiplying together, and these are two different ways that we can do that. So that's the FOIL method. The other method is called the box method. So in the box method, we draw a box for our binomials. We line up each binomial, one on the side and one on the top. We multiply the terms into the box. We write them out, combine like ones, and put it in standard form. And again, I'm going to show you examples of both of these things. So go ahead and pause your video and write down all of these steps for these two different methods. And I'm going to let you decide which method you like better. So let's take a look at number 1. I'm going to FOIL in number 1. So if I FOIL in number 1, that means I multiply the first two terms. So the first two terms are right here and right here, x times x, which gives me x squared. Then I multiply the outside. The outsides are the x and the negative 4, which gives me negative 4x. Then I multiply the inside, which gives me negative 1 and x, so that's negative 1x, and multiply the last, which is negative 1 times negative 4. Negative 1 times negative 4 is positive 4. So really it was this times that, and then this times that. Two sets of distribution. I distributed this first part to both things behind, and this second part to both things behind. That's really what's happening here. I need to always make sure that I combine like terms. So negative 4x and negative 1x is going to be negative 5x, and write it in standard form. So x squared minus 5x plus 4. All right. So now let's take a look at number 2, and we're going to use the box method in number 2. So in number 2, let's draw the box. When I draw the box, I want to make it a 2 by 2. And the reason I make it a 2 by 2 is because I have two terms in this binomial and two terms in that binomial. That's what a binomial is. A binomial is having two terms. So in the box, or I guess outside of the box, I'm going to line up these two binomials. I'm going to put x and positive 2 and then x and positive 5. So I lined up one binomial on the top, one binomial on the bottom. If it helps to remind you, you need to bring the plus and the minus. Really, it doesn't matter if it's a plus, which is what we have for both of these, but if it were a negative, we need to put that negative in there. So now let's multiply the products on the inside. On the inside, I have x times x, which gives me x squared. Then I have x times 2, which gives me 2x. I have 5 times x, which gives me 5x. And I have 5 times 2, which gives me 10. So now I've found the products that go on the inside, and then I need to go ahead and put my like terms together. Now you'll notice if we write out these terms, x squared plus 2x plus 5x plus 10, these are my like terms here in the middle. 2x and 5x is 7x. So I have x squared plus 7x plus 10. That is my standard form product of these two binomials. So let's take a look at number 3. In number 3, I'll go ahead and use the FOIL method again. So I'm going to multiply the first two terms. X times 2x is 2x squared. Then I multiply the outside. X times 1 is just 1x. Then the inside, 1 times 2x is 2x. And the last, 1 times 1 is just 1. Your like terms are the 1x and 2x in the middle, so I have 2x squared plus 3x plus 1. That is my product. And then in number 4, I'll set up a box method. So in number 4, I'm going to draw my box out, and I'm going to line the two binomials up. So I have x, -1, x, -3. So notice that I brought the negatives with my terms this time. Now, one other thing you might be asking is, does it matter where I put the x minus 1 and the x minus 3? And the real answer to that is no, it doesn't, because we can multiply in any order. I could just have easily have written this x minus 3 times x minus 1 and get the same answer. So I can flip-flop these and get the same answer. Now let's find the products that go on the inside. X times x is x squared. X times -1 is -1x. X times -3 is -3x. And -3 times -1 is +3. Write out your four terms. X squared minus 1x minus 3x plus 3. Like terms go together. -1 minus 3 is -4, so x squared minus 4x plus 3, and there we have it. All right. Now, when we multiply a binomial squared, it says when we multiply binomial squared, we cannot just square both terms. That's when I will shame you. I will tell you that that is not okay. You do not just square both terms. You have to multiply the binomial times itself. You multiply the binomial times itself. So now let me show you what that looks like. So in number 5, I have x plus 6 quantity squared. So when I multiply this, I end up with x plus 6 times itself, x plus 6. And that gives me, if I FOIL these, first times first is x squared. Outsides is going to be 6x. Insides, 6x. And last, 6 times 6 is 36. Here are my like terms, x squared plus 12x plus 36. Okay, so that is my actual answer. Okay, and you can see again, I have those two sets of distribution. This first term needs to go to both parts behind. This last term needs to go to both parts behind. We can call it FOIL to help us stay organized. First, outside, inside, last. Now, here's what people try to do all the time. They try to take x plus 6 quantity squared and just do this and call it x squared plus 36. Don't do that. That is bad. Look at the difference. You have x squared plus 36. Here you have x squared plus 12x plus 36. This drops your middle terms. You would have lost out on the O and the I, and then that's bad. You just lose the middle term, and that's bad. Okay, so do not just square both parts and then add them together. You have to FOIL. You have to do the binomial times itself. Let's take a look at number 6. In number 6, if I do the binomial times itself, it looks like this. I'll make a box for this one, just for those of you that would like to use the box better or to see a little bit more practice with the box. I have x and -2, x and -2. My products on the inside, x times x is x squared, x times -2 is -2x, x times -2, -2x, -2 times -2, +4. X squared minus 2x plus 4, -2x and -2x is -4x. So again, if I would have just squared both parts, I would have ended up with x squared plus 4 and lost the middle -4x. Don't just square both parts and leave it. You have to multiply the binomial times itself. Now let's take this one step further and talk about if we're multiplying by more than just binomials. So when I'm multiplying more than just binomials, I need to use the same methods, but FOIL is no longer a good acronym when it's more than two terms, because there ends up being middle terms that'll get dropped out if you use FOIL. So really you just need to make sure that everything gets distributed to everything beside. So we need to use the box method here. The box method is going to be an easier way to organize. Okay, and I'll show you why. You can use distribution. It just becomes really, really messy if you're trying to do it with all of these terms lined up. So here's what the box looks like for something like number 7. I have a 2 terms by a 3 term product, 2 by 3. So that means I'm going to make 2 rows, but I'm going to make 3 columns. So here's my 2 rows, but here's my 3 columns. Then I'm going to line up the 4x and the 9 and the 2x squared minus 5x plus 3 on the top. Now, some of you may ask, could I flip that box and turn it so that it's this way? Sure, absolutely. You could put your trinomial over here and your binomial across the top. It wouldn't make a difference. It works the same way. So now let's look for our products in the middle. 4x times 2x squared is going to be 8x to the third. 4x times negative 5x is negative 20x squared. 4x times 3 is 12x. 9 times 2x squared is 18x squared. 9 times negative 5x is negative 45x. 9 times 3, 27. Okay, now we could go ahead and list out all of these terms, but here's one thing that I want to point out to you. Notice that your like terms ended up on the diagonal. I have this 18x squared and negative 20x squared. For those of you that learned how to do lattice multiplication, this is kind of like that. Lattice multiplication had you line up your one number on the top, one number on the side to set up your lattices that go diagonally, and those were the things you added together. Well, that's kind of the same thing that's happening here. So instead of going through the hassle of rewriting all of these terms again, I'm not going to do that. I'm just going to look on the diagonal and make sure they're my like terms and put those together. So I have 8x to the third that's by itself. Then this squared part, 18 and negative 20 is negative 2x squared. Then the negative 45 and 12 is negative 33x. And the 27 is by itself. Now you always want to check that they are in fact like terms before you add the diagonals, but as long as these were in standard form, then they will be. So then I'm all good. Okay, so let's talk about number 8. In number 8, I have 3x minus 5 times 2x squared plus 7x minus 8. So again, I'm going to start by setting up my big box. Now, again, like I said before, you could go through and do all of the distribution, but there's a lot of distribution that would have to happen here. I would have to go 3x to this one, then that one, and then negative 5 to this one, and that one. You'd end up with this big long string of 6 terms. Go back and find the ones that are in common. It gets a little messy. The box is just a really nice way for us to organize it. So that's what I'm going to use. So I have 3x negative 5, don't forget to take that negative with it, 2x squared, 7x, and negative 8. Now let's multiply. So on the inside, 3x times 2x squared is 6x to the third. 3x times 7x is 21x squared. 3x times negative 8 is negative 24x. Negative 5 times 2x squared is negative 10x squared. Negative 5 times 7x is negative 35x, and negative 5 times negative 5 is positive 40. So again, I'm going to check the diagonals and see if those are my like terms, and they are x squared and x and x. So when I put all of my like terms together, I have 6x to the third. Negative 10 and 21 is positive 11x squared. Negative 35 and negative 24 is negative 59x, and then that positive 40 is just by itself at the end. That's in standard form, and I am all set. Okay, let's take a look at number 9. In number 9, actually the one that's on your notes sheet has this 5 out front. So we're going to talk about what we have to do when we have numbers out front of those trinomials. So to take care of that 5, this 5 needs to be multiplied into the first set of parentheses. Now I'm not going to go all the way across to the second set of parentheses, and here's why. Since I'm eventually going to multiply this set of parentheses times that set of parentheses, the 5 will make it to all of these terms. If you go across this one and across the second one, you're going to end up multiplying by 5 twice, and you don't want to do that. So I'm just going to multiply by 5 on the first set of parentheses and stop there and see what I get. I end up with 5y squared minus 10y plus 25. Now again, that second set of parentheses I haven't changed. So 6y squared minus 3y plus 1. Now I have a big old box that I got to set up. I have 3 by 3. So big box, 3 rows and 3 columns. Here's my 3 columns. There's my 3 rows. And again, the box is really just a great way for us to help organize that distribution that's happening here. So down the side, I have 5y squared, negative 10y, positive 25. Across the top, 6y squared, negative 3y, positive 1. I guess I didn't really need the plus there, but there it is. Now let's multiply. 5 times 6, 30. Y squared times y squared, y to the 4th. 5 times negative 3, negative 15. Y squared times y, y to the 3rd. 5 times 1 is just 5, y squared. Negative 10 times 6 is negative 60, y to the 3rd. Negative 10 times negative 3 is positive 30, y squared. Negative 10 times 1, negative 10, y. 25 times 6y squared, that is 150 y squared. 25 times negative 3 is negative 75y. 25 times 1 is just 25. And holy cow, check it out. Our like terms are still on the diagonal. Y to the 3rd, y to the 3rd. Y to the squared, y to the squared, y to the squared. There's 3 of those bad boys. And then a y term, there's 2 of those. So now let's put them all back together. 30y to the 4th by itself. Negative 60 and negative 15 is negative 75 y to the 3rd. 150 plus 30 plus 5 is 185 y squared. Negative 75 and negative 10 is negative 85 y, positive 25 at the end. It's in standard form. It's huge, but it's in standard form, so we're good. Let's take a look at number 10. In number 10, I don't have anything that's on the outside that needs to be distributed like I did in number 9. So I'm just going to set up the big box for the 3 by 3 terms here. I made that kind of small. Hopefully I can fit everything in there. Sorry if you run out of room on your paper. So I have m squared 2m negative 3. Then I have 4m squared negative 7m and 5. Let's find the products on the inside. 4m squared and m squared is 4m to the 4th. M squared times negative 7m, negative 7m to the 3rd. M squared times 5 is 5m squared. 2 times 4 is 8. M times m squared is m to the 3rd. 2 times negative 7, negative 14. That would be m squared. 2 times 5 is 10, so 10m. Negative 3 times 4 is negative 12m squared. Negative 3 times negative 7, positive 21m. Negative times negative is positive. And then negative 3 times 5 is negative 15. Okay, so now put your like terms together. So I have 4m to the 4th, that's by itself. Then I have the thirds. 8 minus 7 is 1, so just plus m to the 3rd. Then I have the m squareds. I have negative 12, negative 14, and positive 5. Well, negative 12 and negative 14 is negative 26, but the negative 26 plus 5 is negative 21. So negative 21m squared. Then I have a positive 21 and a 10, that's 31m, and minus 15 at the end by itself, standard form. There we go. Whew, one more question and then we'll be done. Number 11, the area of a triangle is half the product of the base times the height. Write a polynomial expression for that represents the area of the triangle in this picture. So what we're given in this picture is a base of 2x plus 3 and a height of 3x minus 1. We're also told that area of the triangle is base times height divided by 2. Half product base times height. We all know that formula. That's a formula we've seen lots before. But now let's take a look at it when we plug in these polynomials. Don't forget to put parentheses around them because that's going to make a difference. So I'll have 3x minus 1 times 2x plus 3 on the top, all divided by 2 on the bottom. Now I'm just going to FOIL the top. This is a 2 by 2, so I can do first, outside, inside, last. That's going to give me 6x squared. Outside is positive 9x. Inside is negative 2x. Last is negative 3 all over 2. And then putting my like terms together, 9 minus 2 is 7. So that's going to be 6x squared plus 7x minus 3 all over 2. Now, at this point, I don't have anything else I can do on the top. What I would check is to make sure and see if I can divide every term in the top by 2. Well, I can divide 6 by 2 and get an even number, but 7 does not divide 2 evenly and 3 does not divide 2 evenly. So that is as far as I can go. I'm not going to simplify anything else. Technically, I need to write units squared because I'm talking about area, and that is my expression. All right, that takes us to the end of our video. So thanks for watching. Don't forget to check your notes sheet off with Miss Johnson, and I will see you all later.